Access is initially made using a number 4 high-speed surgical length round bar, more or less placed in the center of the tooth with a slight bias to the mesial and buccal as the access is widened and deepened. Once we gain access into the pulp chamber, the explorer is used to determine where the canals are and the amount of tooth structure that is overlying the canal orifices. The goal is to remove the overhanging dentin that limits the straight line access to the canal orifices. Once we see the canal orifices unobstructed by overhanging dentin, we are ready to negotiate the canal length with the safe-sider reamers. I chose to initially negotiate the canals with a number 15 safe-sider used manually with a tight watch-winding motion in a well-lubricated chamber, the lubricant for these exercises being tap water. Once I demonstrated to myself that the manual use of the 15 safe-sider negotiated to the apex of the 3 canals with minimum resistance and took my measurements with their reference points, I placed a number 20 safe-sider into the oscillating handpiece and using a gradual up and down motion of an amplitude of 5 to 10 millimeters negotiated to the apex of each canal. When negotiating relatively tight canals, it is not uncommon for some debris to be extruded apically regardless of the technique used. In a real-life situation, the initial placement of sodium hypochlorite would have disinfected most of this extruded material, reducing its irritating potential. In the process of shaping the canals, knowing that separation is virtually impossible, I leaned the safe-siders vigorously against all the canal walls, but particularly those in the buccolingual plane. Irrigating copiously between instrument sizes removes any debris that may have been generated by the instruments and further clears the pathway for the next instrument. The number 20 safe-sider used in the oscillating handpiece allowed me to skip sizes and go directly to the 30 safe-sider used in the oscillating handpiece. Note the control I have when negotiating a canal curved in the apical third. Also note how I can enter the common isthmus between the mesiobuccal and mesiolingual canals, removing sheaths of pulp tissue that are present in the buccalolingual extensions of these canals. As a final step in shaping, I placed a bend of 30 degrees in the last millimeter of 30-degree safe-sider and manually worked it against all the canal walls to even more effectively remove pulp tissue from any potential undercuts. Preparing the canals to a 30-degree safe-sider cleanse and shape the canals, allowing me to now obturate. I fitted fine medium points in the mesial canals and a medium point in the distal canal. My goal is a fit with tugback without going over the apical confines of the root. After drying the canals, I applied the Easy Fill epoxy resin cement using the bidirectional spiral applicator. This instrument floods the canals with cement while preventing its extrusion apically during application. It is used 3 millimeters short of the apical measurement. After coating the canals, the pre-fitted points are liberally coated with Easy Fill epoxy resin cement and placed in their respective spaces. In these mesiodistal and buccolingual periapical x-rays, you can see a 3-dimensional fill that was created using 3 instruments from start to finish. They created a space that was determined by the original canal anatomy, reflecting that original anatomy in larger form.